Okay, we're back for the second part of 3.4 and 3.5, and we were talking about percentiles. And we're going to break our percentiles into 4 quarters, and so they're going to be called quartiles, just like money is broken into 4 parts. So the median is the 50th percentile, or P50, and that's the second quartile, or Q2. So we always call it MED. We rarely ever talk about it as Q2. The first quartile is the 25th percentile, and we call that Q1. And the third quartile is the 75th percentile, and we call that Q3. And so on a box plot, this is our 5-number summary. This is our box plot. This is our minimum down here. This is always going to be our minimum value. This is our Q1. This is going to be our median. For Q2, this is going to be our Q3, and this will be our maximum. Okay. So if you have your StatCrunch open, we're going to go, and there's a data set that says CP. Let's go find it. It's CP from this lesson, CP 3435. And right here. So it asks us, it says the following data set is a set of sample of Math 133 Exam 3 scores from winter 2014. So quite a while ago. And it says find the 5-number summary. So we're going to go into stat, and we've done this before because when we found the mean and the standard deviation way back in lessons 3.1 and 3.2, if you go to stat and summary stats and just hit columns, we're just going to choose that 1 bar that we have there, and we're going to hit compute. And it should give us everything we need. And this white box is going to give us the sample size, the mean, the variance, the standard deviation. Don't worry about the standard error for now. It's going to give us the median, the range, the min, the max, the Q1, and the Q3. So everything we need. Go ahead and hit compute. And there it is. So I'm going to fill it in on my paper, and then when we come back, you'll be able to see and check in with me. So the mean, we don't need, but I'm going to just jot it down on my paper because we're going to need it for the next page. So just below your 5-number summary there, just write X bar equals 80.896. Well, actually 897 when you round appropriately. And the standard deviation S is 10.598. The minimum is 54. The Q1 is 77. The Q3 is 88. The M in that box that we have on our paper, the M is the median, and that's 84. And the maximum is 93. So on one of the projects for chapter 3, I'm asking you to, you'll go and check it out, but I'm asking you to go in and find some data and do complete this summary. And so I want you to find this here, and you're going to be going to options, and then you're going to hit copy, and it's going to tell you how to do that. So you're going to drag the mouse on everything that you want, and then you're going to hit Control-C. So I would go like this and say summary statistics, and I would hit everything and say Control-C, and then I could copy it to where I want it to go. Okay. So let's go back and look at our paper and make sure that we have everything that we need. And notice that I wrote at the bottom the mean and the standard deviation, because like I said, we're going to need that on the next page. Okay, so there's our min, our Q1, our median, our Q3, and our maximum. And this is basically the layout of our box plot. Okay. So another measurement that we're going to look at, we looked at the range back in the standard deviation lesson, which was 3.3. And they want us to find that here, which is the max minus the min. And so that's going to be 93 minus 54, which is 39. And the IQR, so that's up here. The IQR is the interquartile range. It's the range of the middle 50% of the observations of a data set. This is another measure of the variability of a data set. So this Q3 minus Q1, it's the width of the box, the rectangle in the box plot. Okay, so the box that's in the box plot, this is the IQR right here. That's what that measures. And on the previous page, it's good to fill this in, that there's 25% of the data from the minimum up to Q1. Then there's another 25% inside the box to the left of your median marking. There's another 25% on the right side of the box, no matter where that median is. Sometimes it's off to the left or to the right, and that's going to tell us that our data is skewed. And then from the Q3 out to the maximum, there's another 25% of the data, if we were to lay it out from smallest to largest. Okay, so the IQR for our data is Q3 minus Q1. So Q3 was 88.5 minus Q1, which is 76. And so that comes out to be 12.5. And the mean that we wrote down was 80.90, I believe. We left it at 80.897. The median was 84. The standard deviation was 10.598. And the variance is 10.598 squared. So we are going to take 10.598 squared, and that comes out to be 112.318. And it says, describe the distribution of this data set. So I want to know if it's skewed or symmetric. And remember how we tell? It's nice because in the table here, I put the mean on the left and the median on the right. So all we have to do is the inequality, which shows that the median is bigger, substantially bigger than the mean. And so we're going to say that this data set is skewed left. Okay. So when our data is skewed left, we said the best measure of center would be the median. But we did not talk about what the best measure of spread would be, okay? So our shape is skewed left. Our best measure of center would be the median. And our spread, the best measure is going to be the IQR, okay? So when our data is skewed left or right, the best measure of the spread is the IQR. And so we also have to decide, well, then if that's the case and our data is skewed and we're not using the mean and the standard deviation, then I really can't say that a data point is unusual if it's outside of 2 standard deviations, because I shouldn't really be using the standard deviations, right? And so that means we're going to use something down here in this box. It says checking for outliers using quartiles. And then let's just write when we have skewed data. Okay, so we're going to find Q1 and Q3. We're going to then calculate our IQR, which is Q3 minus Q1. Then we're going to find our lower fence and our upper fence. This entire box is going to be really good information to put on your note sheet for the midterm and the final. So our lower fence is, you start with Q1. Notice that they start with different things. So the lower fence is Q1, and you subtract 1.5 times your IQR measure. And then your upper fence is Q3, and you add 1.5 times your IQR measure. And then you go back and look at your data and say, if any of my data points are bigger than my upper fence or smaller than my lower fence, then I can say I have outliers. So letter C down below says, let's see if this data set has any outliers. So we need to find our lower fence, which is going to be taking Q1. So 76 minus 1.5 times my IQR, 12.5. And then I'm going to look at my upper, and that's my Q3, which is 88.5. And this time I'm adding 1.5 times my IQR, whoops, which is 12.5. And so my lower fence is 57.25. And then my upper fence, oops, it should be 88.5. So I took insert 0.5. 88.5 plus 1.5 times 12.5. So 107.25. So go back and look at the data and see if we have any data that's smaller than 57.25. And we can see this by our min, right? Our min and our max. Our min, our smallest min is 54. So we do have, our min is lower. That's going to be unusual, right? And then we can't have a student score more than 100%. So we couldn't have anything in the upper. But the min is unusual because it's lower than the 57. And actually, we have two data points. We have 54 and 56. They're both considered unusual because they're lower than the fence. Okay, so look at the page here. So page 104 here says how to read a box plot, which we've already been introduced to. First, we have a 5-number summary. So we already marked those. Our center is the median. Our spread is the Q3 minus Q1. So that's going to be our IQR. Our range is our max minus our min. And our outliers are going to have symbols. So we have 2 outliers. We already marked those. We said 54 and 56. So these are outliers. That's the nice thing about the box plot is it gives you different symbols for those. So box plots give you lots of information. So it says label the 5-number summary on the box plot. So we did. So our minimum value is here. There's our Q1, our Q3, our median, and this is our max value, wherever that lines up. So what proportion of the scores lie between 76 and 88.5? So this must be 76, and this must be 88.5, right? It's basically our IQR. So we have 25% here and 25% there, so it must be a total of 50%. Letter C says, what proportion of the scores lie above 76? So above 76. So 76 is our Q1, right? And we know that 25% below, they lie below our Q1. So that means 100 minus 25 is 75% lie above. What proportion of the scores lie below 88.5? Okay, so 88.5 is our Q3, and we know Q3 is our 75th percentile, so that's 75% as well. What proportion of the scores lie between 54 and 76? So 54 is our minimum, and 76 is our Q1, so that would be 25%. And then it says, to what number does the left line extend? Explain. So when you have data that is unusual, they're marked by symbols. So the left line is extending to the last data point, the last or smallest, we'll say on the left, smallest data value that is still inside the lower fence. It's not considered an outlier. It's still inside the lower fence. Only those two are low enough to be considered outliers. So this must be 60. When we looked at our data, those two data points were outliers, and then we got to 60. Still inside the lower fence. Okay. So let's just look at what some general box plots look like. Most of the time they're horizontal, which are my favorite. When they're vertical, I like to turn them so they still look horizontal to me. And here are the three possibilities of the shapes. So just like we mentioned in lesson 3.2, 3.1 and 3.2, as far as skewed right, skewed left, and symmetric, our box plots are going to give us indicators of that as well. So if we have a skewed right data set, we're going to have a longer tail on the right, or the upper half of the box might be larger. Okay. If it's symmetric, then you'll notice that the whiskers, the whiskers out here, the tails are about equal, and the median is about in the middle. And if we're skewed left, then you're going to notice that your tail on the left is a little bit longer, or you're going to have more space over on the left. Okay, so we'll get practice looking at these on some worksheets in class. And then last but not least, we're putting it all together on everything from chapter 3 here. So we're going to fill this in. So this shape right here, when the mean on the left is less than the median on the right, our inequality is pointing left. This is a skewed left shape. Okay, and our box plot would probably look something like this. Okay, where we're going to have a longer whisker on the left. Our mean versus our median is going to be, geez, a less than. So mean is going to be less than the median. It's written up there. And the best measure of center is going to be the median. And the best measure of spread is the IQR. And that's the same for the skewed right. So let's go over here and do the same thing. So this one is skewed right. And you can see that the median is less than the mean, but we're going to write it as mean compared to median. So it's this way this time. The mean is greater than the median. And this time our box plot might look something like this, with a longer tail on the right and longer space on the right. Again, the best measure of center is the median, and the IQR is the best measure of spread. If our data is symmetric, then we're going to say symmetric. And then our box plot should look fairly symmetric or so. The tail should look about the same. And the mean is going to be approximately equal to the median. And in that case, our best measure of center is going to be the mean. And the best measure of spread is going to be the standard deviation. So this whole box is going to be really important to have on your note sheet for the midterm. It's little bits and pieces have been throughout the whole chapter of 3, but I would just put one box where it's kind of all summarized together. and make sure that you are understanding the shape, center, and spread. So the shape is up here, skewed left, symmetric, or skewed right. The center is, if it's skewed at all, we're choosing the median, otherwise we're choosing the mean right here. And then the spread is going to be standard deviation if it's symmetric, or it's going to be the IQR if it's skewed. There's a lot in this lesson, so if you need to go back and rewatch something, I really recommend taking your time and doing so. And I will see you all back for chapter 4 soon.